Hi guys, welcome to Pre-Calculus 11 1.2 Arithmetic Series. We'll start off with our PLOs again. For this section we'll be deriving a rule for determining the sum of an arithmetic series, and we have to determine the values again of t1, d, n, and the new one, s of n, in an arithmetic series. And the final one is to solve word problems. Let's start off by asking what an arithmetic series is. It's basically the sum of all the terms in an arithmetic sequence. The key word is sum. We've done arithmetic sequences last section, where we learned about patterns where you add or subtract the same number each time, and we tried to find different terms. But in this section, you're just trying to find the sum of all these terms, so it becomes 5 plus 7 plus 9 plus 11. There are two formulas, as you can see. First formula is S of n equals n divided by 2, and then in brackets 2t1 plus n minus 1 multiplied by d. Or the second formula is S of n equals n divided by 2, and in brackets t1 plus tn. The only key difference between the two is, for the second formula, you have to know what tn equals. So I'll just go over what each of these variables mean. S of n just means the sum, the total sum, what you're looking for. That's the answer you're looking for. N is the number of terms in the sequence. T1 is the first term again. And D is the common difference. So for this example, that would be 2, because you're adding 2 each time. And the only difference for this equation is where T of n is the last term in the sequence. So if you know the last term of the sequence, then you can use this formula. Otherwise, you'd have to use the first formula each time. So let's go down and start practicing. Our first question shows a pattern of 2, 4, 6, 8, 10. So let's just write one thing down. We know that the common difference is plus 2 because you add 2 every time. And the question is asking us to find the sum of the first 30 terms. So the first question we have to ask ourselves is, do we know the last term, t of n? Well, it shows ... We don't know. So the answer is no. So we'll have to use our first equation. So we can just cross this one off. Let's go to our first equation. We write that formula down. S of n equals n over 2, and then in brackets 2t1 plus n minus 1 multiplied by d. And then we can start filling in some of the missing parts. So we know that the sum of 30 terms, the first 30 terms, and we can also fill that here. We know that it's 30 terms. And we know that our t1 in this equation is 2. That's the first number in the pattern. And we know again it's 30 terms. And the common difference, as we figured out, is 2. Let's multiply everything out. So 30 divided by 2 gives us 15. 2 times 2 gives us 4. 30 minus 1 is 29. 29 times 2 gives us 58. So to give us a final answer of 930. So we know that the sum of the first 30 terms in that equation, in that sequence, is 930. Moving on to our second question. Now we know that the sum of the first 2 terms is 13, but the sum of the first 4 terms is 46. Now the question is asking us to find the first 6 terms. That's all. So, like the previous section, we have to create 2 equations and then try to eliminate one of the variables. Let's start with our first equation. So we have our equation here, and we can fill in some parts. So if we use sum of 2 equals 13, we know that Sn equals 13. We know that it's the second term. We don't know what term 1 is yet, or the difference. We don't know what the difference is, but we don't know, again, it's the second term. So after you multiply everything together, so you should get 2 over 2 gives us 1. 2t1 remains the same. 2 minus 1 is 1. 1 times d gives us d. So that's our final answer. And then let's do it for the other equation. Start off with the formula. Fill in the missing parts. S of n gives us 46 this time. But then we know that this is the sum of 4 terms. So we put in a 4 over there. And then we put in a 4 over here as well. But then we don't know what the difference is yet. So now after we multiply everything in, we get 4 over 2 as an answer of 2. we get 2t1 that remains the same, and then 4 minus 1 is 3, 3 times d gives us 3d. But the problem is now we have 2 times everything, so to get rid of the 2 we'll just divide everything by 2. So divide the whole thing by 2, which means 46 divided by 2 is 23, and this divided by 2 just cancels the 2 off, which just gives us 2t1 plus 3d. So there's our two equations. 13 equals 2t1 plus d, and 23 equals 2t1 plus 3d. So we can get rid of one of them. We can get rid of t1s because they're the same value. So 13 minus 23 gives us negative 10. 2t1 minus 2t1 cancel each other off. d minus 3d gives us negative 2d. Now we have to isolate for d. That means get rid of the negative 2. So divide both sides by negative 2. Gives us a common difference of 5. So now we know the common difference, and we have to look for the first term, because without the first term we don't know what the first 6 terms will be. So we'll use one of our equations. I've decided to use 13 equals 2t1 plus d. Fill in the missing part now that it's d, which equals 5. Now subtract 5 from both sides, which means that 8 equals 2t1. And now we have to isolate for t1. So divide both sides by 2, giving us the first term of 4. So now we have the two key pieces of information. First term is 4, and the common difference is 5. So we start off with 4 and add 5 each time to get the first 6 terms of the pattern. Third question shows us 7, 14, 21, all the way to 98, and just one question. It asks us to find the sum of the sequence. Always, the first question we ask ourselves is, do we know the last term of this sequence? This time we do. We know that it's 98. So we can use the second equation. So the second equation is S of n is n divided by 2 multiplied by t1 plus tn. So let's fill in everything else. We know Sn. We don't know how many terms there are in this sequence. We just know the numbers, so we have to leave n out for a second. We don't know what that is, but we do know what the first term is. That's 7, and we know what the last term is. That's 98. So we add those two up. We get 105. So we get a final equation of 105n divided by 2. But if we don't know what n is, we can't go any further. So let's try to solve for what n is. So this uses our knowledge from the previous section, where you try to find out what term 98 is. So we start off with our general term formula, and we fill in everything else. You're looking for which term 98 is. So we know t of n is 98. We know the first term is 7. And we know that the common difference is 7 because you add 7 each time. So we multiply into the brackets. So we have 98 equals 7, that stays the same, plus 7n minus 7. The two 7's cancel off, which gives us 98 equals 7n. Solve for n by dividing by 7. And that gives us an answer for n, which means that 98 is the 14th term of the sequence. So now we can fill in 14. So the sum of the 14 terms is 105 times 14 divided by 2, which means that the sum of the first 14 terms in the sequence is 735. Let's move on to the next question. This gives us three key pieces of information. It shows that term 1 is 7, last term is 79, and that there are 8 terms. And we are asked to find the sum of the sequence. So do we know the last term? Yes, we do. Yes, we know the last term. It's 79, so we can use the second equation. So let's fill in the information here. We know that it's 8 terms, so 8 will go in those two corresponding regions. We know the first term, that's 7. We know the last term, that's 79. And then we just solve for the equation. So let's do what's in the brackets first. 7 plus 79 gives us 86. And 8 over 2 gives us 4. 4 times 86 gives a final answer of 344. One more problem like that before we head into the word problems. Again, we have 3 key pieces of information. D equals 6, Sn equals 574, and n equals 14. And we are asked to find the value of t1. this time we don't know what the last term is, so we'll have to use our first equation that's right there. So as we fill in everything, we get that S of n is 574. We know that there are 14 terms involved, but we don't know what T1 is, but we do know what the difference is. That's 6. So let's multiply everything in. That 14 divided by 2 gives us 7. 2T1 remains the same. 14 minus 1 is 13. 13 times 6 gives us 78. That we have that, but we have to get rid of our 7 first so that we can solve for T1. Divide everything by 7, both sides by 7. That gives us 82, which equals to 2T1 plus 78. Now we have to get rid of our 78, so we subtract it on both sides. Once you subtract, you get 4 equals 2T1. You have to get rid of the 2, so divide both sides by 2 for an answer of T1, which is equal to 2. Oh, sorry, there's one more question before the word problem. Again, 3 key pieces of information. First term is 8, last term is 68. The total sum is 608. Let's solve. We know the last term, so we can use the second equation. So let's start off with that. The only missing piece is we don't know what the sum, how many terms are in this sequence. So that's what we have to solve for. We know that the total sum is 608. We don't know how many terms there are, so that's left as n. We know the first term is 8, the last term is 68, and then we just solve for n. So 608 stays the same. We just add 8 and 68 to give us 7. But what we have to do is get rid of the divided by 2. So we multiply both sides by 2. That gets rid of the division. So we have 1,1216 equals 76n. Now we have to get rid of the 76, so we divide both sides by 76, giving us a final answer of 16. That means there are 16 terms in that sequence. And our final question. There's a clock that chimes the number of times that corresponds to the time, which means if it's 4 o'clock, it chimes 4 times. So how many times does the clock chime in a 12-hour period? So we'll start off with 1 o'clock, so it chimes 1 time, 2 o'clock, 3 o'clock, 4 o'clock, all the way to 12 o'clock. So it does that, and now we have to use which formula we can. I decided to use both formulas just to show you that you get the same answer in the end. So with the first formula, you substitute the values. We know that it's 12 terms because it's a 12-hour period. You can put that in all those 3 places. We know that the term 1 is 1 because the first time it chimes is when it's 1 o'clock. And we know the difference is 1 also because you have to add 1 each time. You add 1 between each of the terms. So the difference is 1. So let's multiply everything here. 12 divided by 2 gives us 6. 2 times 1 gives us 2. 12 minus 1 is 11. 11 times 1 gives us 11. Now after we just add the 2, so 11 plus 2 is 13. 13 times 6 gives us a sum of 78. So in a 12-hour period, it'll chime 78 times. Now let's use the second formula. S of n, oh, that's supposed to be an n, that's the second formula. So we know that it's again 12 hours, so we put 12 over there. And we know the first and the last term of the sequence. We know that it chimes the first time when it's 1 o'clock, and it chimes last time when it's 12 o'clock. So we just add 1 plus 12 gives us 13. 12 divided by 2 gives us 6, for a final answer of 78 again. So that's it for chapter 1.2. I hope that was helpful. Thank you very much.